Although we've had tons of fun doing this, it's time we wrapped it up. So this next section, we're going to have a look at what we've done. We're going to admire our work and realize that this project will go on and on and on using the same strategies and philosophies that we've been using all the way along. So what I'd like to do is during the break, I added a little bit of an animate function. And what that does is if you add a circle, for example, and then push it, rather than just moving it, it actually animates it. So if you look at a rectangle, it'll then animate it. Now again, this created a whole bunch of other things that we would look at and we would continue to work on. So for example, the shape moves out of the panel area and we would need to fix that. But for right now, we're going to leave it. That's good. This will go on for days and days and days. What I want to do is have a look now at what we've done. I'm going to look at the index.js file, and I'm going to clean that up and make sure all the code that we don't need anymore has been removed. Now, if the key, we're just going to run that animate function. We're going to get rid of the console logs, which we don't need. Here's areas here. Here's areas here where we've created constants that we don't actually use anymore. We use them for debugging purposes. So we get rid of those. We don't need those anymore. And get rid of these console logs. And again, it's really important that your code looks good. We didn't actually use the show button anymore. We're done with it. So as you can see, using the philosophy that we created, we put a lot of functionality inside of here. And with lots of blank lines, we only have 30 lines of code in our index.js file. That's really important. All the other code has been moved into our problem-solving code here, and we've been able to test all of that problem-solving code. So we're just going to save that. Everything's going to work just like it did before. I want to have a quick look at our shapes, remind ourselves what we did. So we had the hello function that we played with. So we created the shapes class, the shape class. The shape class has a constructor, and then we moved 3 methods into the shape class. And this shape class now is the parent of the other classes, the rectangle class. So it extends shape. And as you can see, we're overriding, and this is how you override a method that exists in the parent class. And in some cases, I want to show a case. So we use the super here. So you see in this particular case, we're saying, I want to run the parent's version of this method. Okay? So it's pretty cool. We've seen circle and how that works. We have drawing. Now, the really important thing I want to talk about drawing is this is what I consider to be the controller class. This is the class that everything talks to, and as much as the detail that can be hidden behind all the other methods are what we want to do. So we just talk to everything through the drawing class, okay? And remember, we've gone through these methods. Now, this code needs some serious refactoring, and we could have a whole new session on how to refactor code. But for right now, we're going to leave it at that. So let's go back and just have a little look at what our objectives were and see how we are with our objectives. Stretch this out a little bit. So I wanted to talk a little bit about how do we build software that lasts. And you've witnessed, as we were coding here, the things that we were doing. But I want to talk about them and make sure everybody understands that. I wrote very little increments. One line, as close to one line as possible. So when things went wrong, I was able to address them and deal with them right away. Once you discover the bits, you throw the rest away. Remember we went through that discovery phase? We didn't go through the discovery phase until we had our code working. We went through the discovery phase until we had all the pieces we needed, and then we started incrementally writing tests and putting them into production. Don't save that stuff. You need a testing mindset, and a testing mindset needs to be learned. So please practice it when it's easy. Because people say, oh, I'm going to do TDD when it gets tough. No, actually you won't. You have to learn it when it's easy. You have to learn it where it's practical, and you have to learn how to use it effectively. This code we wrote way quicker because we were using test-driven development. Separation of concern. You saw how we separated the code. We will separate code between business logic, presentation logic, and browser-specific code, and anything else that we might do. Any way that we can separate our code, we'll do it to make our code a little easier to run. And again, the code we wrote needs major refactoring, but it's working code. We have tests to support it, and now we can go in and start refactoring it. As much as you can, develop in pairs or in groups. Your productivity is higher, you learn more from working with each other, and you develop way better code. So as a wrap up, I now want to spend some time talking about what we created here. We created a shape which was the base of all of our shapes. This was the parent class. Circle inherited from shape, rectangle inherited from shape, square inherited from rectangle, and you can see now how that whole idea works. In many programming languages, you wouldn't be able to instantiate shape. Shape would be considered an abstract class. Drawing made heavy use of all the shapes, but as you saw, drawing was a controller class. It controlled the activity, so it allowed us to do work with the shapes without needing the rest of the world to know everything that was going on inside. So that was really quite nice. Now, we never did write the app error. That I'll do a separate session on. Separation of concern was critical in this. We use the JEST framework to create unit tests and functional tests. This made sure all of our code was working the way it could. And you saw from our index.js file that we put the minimal amount of logic in here that we could. 30 lines of logic allowed us to run all that functionality that we were doing. That's pretty freaking cool. Now I want to go back and talk a little bit about the pillars of OOP, object-oriented programming. And the reason I want to talk about that is we now have an example that we can talk about, that we can put a little meat on the bones. So when we talk about inheritance, we talk about the way that the classes inherited functionality, inherited properties, and methods. Abstraction was the ability of being able to hide out details. And again, abstraction, the higher you went up the level, a shape is a way more abstract concept than is a square or a circle. Encapsulation, you saw how we created methods and helper methods inside of our code to get into the implementation details. When we're using that code from the outside, people using that code from the outside don't need to understand all of the complexity that went inside of the classes. They just basically want to know, I want to add a new shape to the panel, I want to move that shape, and we don't have to worry about all the detail about how it happens. That's what we mean by encapsulating that code. Polymorphism. So one of the examples of a polymorphic method might be the move method. So the way we move a circle is slightly different than the way we move a rectangle or a square. The attributes are slightly different, so that could be considered polymorphic. But again, a much better polymorphic example is with the Excel products, the way that a write works, the way that a print works. It works way different in every one of those products, but we know what print means. We know what save means. It's just the way they do it is completely different. And again, this is a fairly articulate explanation. I really liked it, and I'll leave a link here. All right, hope you learned a ton. This was fun for me. I hope it is interesting and you can learn a lot. Thank you very much for all of your patience.